Okay, so we discussed everything, but I guess so we're going to go explore these questions. Okay, it's the assignment. Let's we do together. You take a piece of paper. Let's go ahead with these questions. You guys, can you hear me, right?
Yes.
Yes, can. Okay, can see the questions. Okay, before we do the questions, okay, another one round. We do need to do this many times. Okay, let's recall back all the equations. So first equation is what? PV over T is constant. Next is what? PV equals to and RT. The other one is what? PV equals to and KT. Okay, then and what? PV equals to 1/3 and M C squared. Very important term, mean square speed. Then we did what? P equals to 1/3 rho C squared. Then finally, kinetic energy of mc squared was what? 3/2 kT. Remember this, these equations to be used. Okay. 1, 2, 3, 4, 5, and 6. Okay. So let's go to the first one. 2 minutes. Take a piece of paper, read the question, try to figure out which equation most suitable. How do you go about? 2 minutes for you. Is there anybody? First question, which formula? 1 to 6. Calculate the root mean square speed of the nitrogen molecule at 17 degrees Celsius. Anybody? 1 to 6. Yeah.
1/2 M C squared equals to 3/2 KT.
Yes, the last equation to be used. So you find your mean square speed, then just square root, you get the root mean square speed. Show the working, come on, write the working. Yeah, sorry. Look at this.
So root mean square speed means that it's the square root of the mean speed, right?
Yeah, correct.
Why does it say those words?
Root mean square.
Root mean squared, not root squared mean. No.
Root of the mean square speed.
Root of the mean square. Oh, okay.
Root of the mean square speed.
The mean square.
Okay. Start working. Let me open up. You should know the equations. I hope you have this file with you. Okay. Okay, you can access it. No need to rely on this. I just open up at the side here. So easier. So mass is given. Mass, you know, Boltzmann constant is constant, you know, the temperature 17 degrees Celsius. They are asking for root mean square speed. They're asking root mean square speed. You can't directly find the root mean square speed. No. So we have to find the mean square speed. So of course half mc squared equals to 2 kT. So find your mean square speed. 2 kT divided by what? Yeah, the half m. K, you know, temperature 70 degrees Celsius. You should know you have to convert to what? Plus 273.15. Convert it to Kelvin. Mass of what? Mass of nitrogen is given 4.7 times 10 power of 6 kilogram, 26 negative 26 kilogram. Then you can work out the answer. Whatever answer you got here, you square root it, you get the mean square speed, root mean square speed. Okay, take a piece of paper, get the working, everyone. Okay, so these are the equations. I close it. So I already show you the idea. Okay, get the answer. Okay, so all of you got the answer, 506 meter per second. The equation must be the number 6. Okay, it's a little straightforward. Okay, now those who done with the 1 got the answer. Try the next one, number 2. 2 minutes for you. Yeah. Use the following data to calculate the mean kinetic energy of the ideal monoatomic gas at temperature 27 degrees Celsius. So what's the formula again? Number 6, right? So 3/2 kT, but K is not given here, but real exam K is given. You can stick with 3/2 kT. But the second question trying to remind you that 3/2 K is actually what? R over NA. So R you know here, NA you know, you substitute also you get the same answer. 6.24. Does everyone get the working? Kinetic energy of a particle. 3/2 kT must come to your mind. It's for one particle, not entire gas. 3/2 kT for one particle. Okay, so all of you got 6.24 times 10 power negative 21, sorry. No problem, Guys, any problem? Number 2. Hope you write the answers because these questions we don't have answers. You don't know working. You have to get the working. Okay. Okay, so those done with 2, continue with 3. Number 3 now. Okay, so number 3, try to get answer. Number 3 is proving. Show that the density is MP over RT. M is the molar mass of the gas. From PV equals to nRT, you must bring in density in this formula. And you need to show this. Okay, so we got the number 3 one. So from PV equals to nRT, you must show to density is MP over RT. What type of changes you must done? You must bring a density here. But first, before you bring density, what do you change first? Anyone? You need to bring density, but we need to bring the molar mass too. Which one you can replace as a molar mass?
M.
So M, yeah. M is what? Mass over molar mass, RT. Yeah, correct. Then try to bring in density, you got the answer already. Capital M is molar mass. Small m is mass of the gas. So how do you get density? You need to bring density now. V here, density is what? M over V. Capital M you can put here, right? RT. And this is your MP lah. MP, this is already your density, RT. Then you can rearrange to this one. This is number 3.
So what is E right there?
Oh, this is your density.
Oh, E. Oh, P. Oh, is it P? Okay.
Okay, so this is number 3. Just substitution lah. How do you bring in mass? Number of mole can change to mass, and the density. Okay, I think the first 3 questions like a warm up, not a tricky one. I think 4 onwards can be trickier. Those who done with the 1, 2, 3, figure out number 4 now. 2 minutes for you. Okay, number 4 now. Scroll up.
And so is that 3RT over 2? The over 2 is for the whole 3RT, right? Or is it T over 2?
Well, same one. It's the same. So you can go. You want to take all or only T over 2? It's the same division, right?
Yes.
Yeah. Using the comparison, the kinetic energy of 1 mole of free electron in the metal T may be written as 3RT over 2. 3RT over 2, remember, that's the kinetic energy of one particle or 1 mole of substance. It's for 1 mole. 3RT over 2 is for 1 mole kinetic energy. Okay. Calculate the kinetic energy of 1 mole of free electron at 20 degrees Celsius. Oh, this is straightforward, right? Just the temperature, put 20 degrees Celsius, you get the 1 mole of kinetic energy of the electron. Okay.
So why
3 over
is
2.
it why does it say right here RT, even though the equation is 3 over 2 KT?
Okay. 3 over 2 kT is kinetic energy of one molecule or 3 over 2 kT?
One molecule.
One molecule, right?
So that means R is for 1 mole, is it?
R is for, yeah. So you see, one molecule is 3 over 2 kT. For 1 mole, how do you get? You do 3 over 2 kT times Avogadro constant, correct?
Yes.
So you know 3 over 2 K times Na times T. K times Na is what? K is actually what? R over Na. What? So Na cancel. So 3 over 2 RT is actually kinetic energy of 1 mole of gas. Very low profile are these values. 3 over 2 RT is quite low profile. 3 over 2 KT for one molecule is the most they asked. Okay. Okay, now check the answer for the first one. Kinetic energy of 1 mole of free electron at 20 degrees Celsius. The temperature change to Kelvin. You can't put degrees Celsius. Okay. You get 3.65 kilojoule. First answer is what? Kinetic energy for 1 mole. 1 mole is what? 3 over 2 RT. So 3 over 2, 8.31 times 20 plus 273.15. Should give you the, I think should give you 3.65 kilojoule. That should be answer A, correct? Okay, now look at B. The mean kinetic energy of a free electron. Anybody can answer me? Kinetic energy for 1 electron. So 3.65 kilojoule divided by what? Avogadro constant, right? Because this is the kinetic energy for 1 mole. 1 mole consists of Avogadro constant. So 3.65 divided by Avogadro constant, you get a kinetic energy of 1 electron. Avogadro constant, I believe you remember, 6.02 times 10 to the power of 23. Should remember. So you should get 6.06 times 10 to the power of 21, negative 21 joule.
Kilojoule.
Kilojoule or joule you got? 10 to the power of negative 21 joule, right?
Oh yeah.
Joule, okay. Okay.
So when we use Na, do we use 6.02 or 6.0 only?
We have to check from the front page of your
So it
paper.
depends on the front page.
Yeah, front page. I think they give 6.02, if I'm not mistaken.
Okay.
Front page of your question paper, they'll have the constant, right? Check how many significant they give you. I think 6.02. Okay, so I hope you're done with the part A and part B1. Now the tricky is part B2. Come on, get me the answer. 3.69 times 10 to the power of negative 20 joule. How are you going to get it? So I think same way, right? If you can straight away use 302 KT if you want. If you want, you can use straight away 302 AT. Okay. B2, B2 kinetic energy of 1 electron at 1500 degrees Celsius. So the formula must be 302 KT particle. So 302, your K value, then the temperature, 1500 change to Kelvin, put it here. Kelvin. Then you should get an answer. 3.69 times 10 power of negative 20.
So I got 3.67.
3.67 times 10 power negative 20.
Yes.
Slightly different. 1500 degrees Celsius plus 273.15.
Is it because I use a different value of Boltzmann constant, like the decimals?
Oh, yeah, correct. Boltzmann constant, if we go through from this book paper, sorry, how much is the Boltzmann constant to be used?
1.38. I saw that.
Yeah, 1.38. Yeah.
1.38. Is
38
it
and 10 power
67 3.15 I added?
Yeah. Back to the question.
Yeah, I still got 3.67.
3.67. The others, you get 3.69. Anyone? Anybody get 3.69?
I also got 3.67.
3.67.
I also get 3.67, sir.
3.67. Okay, so 3.67. Slight different. But this is the method. 3/2 kT. Okay, so number 4, still I feel okay. Okay, so come on, guys. Number 5. Okay, so number 5. 2 minutes for you. Try to get by yourself the answers in the bracket. Standard temperature pressure. You know the value, right? Standard temperature pressure is 100,000 Pascal. STP. Yeah, 100,000 Pascal, and the temperature is 0 degrees Celsius. Okay, STP pressure is 100,000 Pascal, and temperature is 0 degrees Celsius. Okay. This question a little looks a little challenging. The RMS speed of hydrogen gas at STP is 1840. This is your root mean square speed. And this is your root mean square speed. Root mean square speed, remember the symbol should be what? Root mean square speed. Root mean square speed is 1080. 1840. Calculate its new RMS speed. Or calculate the new RMS speed. How much the new RMS speed? New RMS speed for a different temperature, 100 degrees Celsius. 100 degrees Celsius. This is 0 degrees Celsius. 0 degrees Celsius, root mean square speed found to be 1840. For 100 degrees Celsius, what is the root mean square speed? So answer is 2150. How do you do this? Anyone? So half mc squared is found to be equals to 3/2 kT. So from here we can say the mean square speed is proportional to temperature. This is the point we have to use. Okay. Mean square speed is proportional to temperature. So that means mean square speed over temperature must be constant. That means what? Mean square speed, the first one, over the temperature of the first one equals to mean square speed of the second one over the temperature of the second one, because constant. Use this technique. Can you work out 2150? Because the mean square speed proportional to temperature. But the question asking for root mean square speed. So when you calculate, you can't use root mean square speed. Find the mean square speed first. Then you can find root it. You can find the root mean square speed. So the T1, you go for the first situation. T1 first situation, how much? 0 degrees Celsius. That means 273.15 Kelvin. Mean square speed for the temperature 273.15 Kelvin, how much? The 1840, what do you do? This is root mean square speed. This is your root mean square speed. Mean square speed, how do you find? Root mean square speed is 1840. So mean square speed is what? 1840 square, right? Square. Yeah, so here you put 1840 square. Square. Then you find the mean square speed for the second one, where the temperature here load how much? 100 degrees Celsius. So the temperature here you put how much? 373.15. So then you find the mean square speed. Whatever mean square speed you got, you root the value, you get root mean square speed. Okay, so you get 2154 meter per second, everyone. Okay. So if you got 2154, the first comparison. They're asking for root mean square speed. You should think like this. The mean square speed proportional to temperature. So mean square speed over the temperature is constant. Okay. So C over T must be same. They substitute, but temperature must be in Kelvin. Okay. So whatever answer you got this, you must change to, sorry, whatever answer you got here, you must square root it to get the RMS value. Okay, so that's the, hope everyone got 2154. Slight difference fine. What is the answer? Anyone? Anyone got 2154?
Yes, 2154.
Yes.
Okay, good. Next, find the pressure. They want at 100 degrees Celsius, they want the pressure, the volume kept constant. At 0 degrees Celsius, at STP, at STP, the speed is 1840. At 100 degrees Celsius, they're asking pressure. I think speed not required here. Anyone? What formula to be used to find pressure?
P1 over V1 equals P2 over V2.
Yeah, right. P1 V1 over T1 equals to P2 V2 over T2, or P1 V1 equals to P2. Volume constant, right? Or volume kept constant. So no need to have volume law if you want. So volume is kept constant one. So P1 over T1 equals to P2 over T2, and to be used to find pressure. The first situation, the pressure is found to be how much? Pressure is 100,000 Pascal. STP is 100,000 Pascal. And the temperature is 0 degrees Celsius. In Kelvin is 273.15 Kelvin. And second pressure we are looking for, and the temperature is found to be 373.15 Kelvin. Yes. So this is the working you should thought of. And the P2 must get 136 kilopascal. Okay, so I hope everyone gets 6 kilopascal. It's actually the formula must come to your mind is P1 V1 over T1 equals to P2 V2 over T2. Two sets of reading has been given. So we can use this formula. Those who figure out this is the formula, good. So you are on a correct track. Because volume is same, so we can cancel the volume. Volume same, so this end up getting P1 over T1 equals to P2 over T2. Okay, so now comes to another good question. Last part. After find the pressure, compare your answer for the speed of oxygen molecules at 100 degrees Celsius. Compare your answer for the speed of oxygen. Earlier what gas? Earlier was hydrogen. So they want to compare the hydrogen speed with oxygen speed at 100 degrees Celsius. Oxygen relative mass is 32. Hydrogen is 2. This is relative mass, relative atomic mass. Oxygen is relatively very heavy. So of course, the speed should be smaller. So you look at the answer, they want the ratio of speed of hydrogen to speed of oxygen. You need to get 4. Okay, 2 minutes for you. Come on, figure out. So they are comparing oxygen with hydrogen. Compare the speed of the oxygen molecule. Speed of the oxygen molecule. The speed, they just put speed. So this speed, you go for mean square speed or root mean square speed? Is it, they just put here speed. That means you take the speed as root mean square speed or you take it root mean square speed. Do they asking for ratio of root mean square speed of hydrogen to oxygen, or do they asking for mean square speed ratio? Hydrogen, oxygen. Which one do you think? Because you see that here they take compare your answer for the speed. So you go for ratio of root mean square speed, or do you go for ratio of mean square speed? Anybody? They just say speed.
Root mean square.
Very good. You have to go for root mean square. Root mean square is like the average speed, the speed of the molecule. Mean square speed like v squared. Root mean square is like a v. It's like the v, actual v. So you're looking for ratio of the mean square speed. So how do you do that? So the kinetic energy of the oxygen must be same as the kinetic energy of hydrogen, correct? Because both must have the same kinetic energy, because both exposed to the same temperature, 100 degrees Celsius. If both a gas in the same temperature, they must have same kinetic energy. That's the final conclusion of this topic, right? So half m c squared of oxygen, this oxygen, should be equals to half m c squared of hydrogen. Those who got the first point, good. Kinetic energy of both gas is the same because they are exposed to the same temperature. So this must come to your mind, next level. So looking for c squared hydrogen, right, over the c squared oxygen from here. So c squared oxygen, what do you get? Half cancel. So it's going to be mass of oxygen over the mass of hydrogen. But because we want square root, so here also square root. So this is your final answer, because we want root mean square ratio. So the answer should be what? Root of mass of the oxygen is what? 32 over mass of the hydrogen is what? 2. Get 4. Okay, so this is how the flow should be for question 5. You must, by heart, you must remember this. Two gas, different gas, if they are exposed to the same temperature, both has same kinetic energy. Okay, that's the very important point you must, by heart, you want need to understand. Okay, so they have the same kinetic energy. Whatever it's heavy or lighter, they're exposed to the same temperature, they have same kinetic energy. Only the speed is different. Speed going to be different. Massive one will have less speed, of course. Whenever they say speed, you go for root mean square. Okay. Any part you don't understand? Okay, guys. So I helped you up to 5. I helped you up to 5. So those who want to take a picture, you can take a picture. So 6 going to be by your own. Okay. So question 6, I want the working. Okay, you can WhatsApp to me. Okay. You can send me the working by not today. Today I think late lah. Maybe by before tomorrow's class lah. Tomorrow 8 o'clock, right? Our class. Okay. So try to get the working for this question 6. Okay, and WhatsApp me before next class. Okay. Tomorrow 8 o'clock you send me at 7:55 also can. Okay. So try to figure out the working for this number 6. Okay. So any questions, guys? No questions, Okay. So figure out the number 6 and send me before next class. So another one class we spend for this topic. The next class, what are we going to do? We're going to discuss the pass-year of idle gas. Okay, pass-year of idle gas, and then we go to the next topic. Okay, any questions? No questions, Okay, I want everybody must send this to WhatsApp to me. Okay, so last time I think 1 or 2 of you didn't send to me. I want everyone to send to me. Okay, so important. Number 6. Okay, so good. So see you then tomorrow.